Okay, I want to give you an explanation for essential question number 2, version 4 in the fall of 2011. I'm going to do things a little bit different from last time. My usual method is to break things up into here's a sequence and here's a sequence. What I'm going to do now is give you the idea that you actually stack these things up when they make sense. And so what I'm going to do here is note that you've got something that looks like a constant series right here, something that looks like a linear gradient series here, and something else that looks like a constant series here. The way I'm going to break this up is I'm going to think about it as having a constant series from time period 3 right there going all the way across over here to time period 16. So I need something that's 3 high there. I'll stack a linear gradient series on there, and that linear gradient series will go all the way to time period 10. And then time period 11 I'll have some extra constant series that will extend out from on top of that one that's 3 tall. So let's work on sticking this together. So we're going to find the present value, and let's get the present value of those 3's. So we're looking for P, given that we know A, whatever the interest rate is, and we'll fill in what the N is, and we know that's something that has to be time shifted. We have also this linear gradient series right here, and so what we're doing is noting that it goes up by 2 each time, and so it's something that goes up by 2, and we're looking for P, given that we know G. There's an I. We'll figure out what the N is, and we'll also do a little time shifting there. And then finally, we've got this other constant series that sits on top of the 3's. So it's that part that's right there. And this is something which is, let's see, what's 11 minus 3 is 8. Something that's 8 tall. So we're looking for P, given that we know A. Here's the I. We'll figure out what the N is. We also know that that one has to do some time shifting too. So that's the basic frame for us. Now let's go ahead and stick in all our n's and exponents, all those unknown parameters. So let's start with those 3's. It turns out there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those. See if I got those right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right, so I put the 14 in there. Yeah, it's true. All I did was count. And then I know I have to do some time shifting. The last time I see those 3's is in time period 16, so I'm pretty sure there has to be a 2 there. Another way of thinking about it is, see that time period right there just before the 3 start? That's time period 2. And so essentially the numerator just takes all those values and dumps them into time period 2. And that little part right there in the denominator shifts it back to time period 0. Now let's play with the linear gradient. So this is the thing that sits on top of the 3's, and so that's this increasing chunk right here. And what we do is we see 1 of these, 2 of these, 3 of these, 4 of these, and then we add 1 to the pot. So this one should be a 5 right here. So it's a 5-element linear gradient series. And if you think about it, for a linear gradient series, the first time you see a chunk of it should be in time period 2. So this means that for the linear gradient series, this should be time period 1, and this one should be time period 0. So if I go ahead and stick a 5 there, I know that I'm, starting it off at time period 0, and if I add these 2 together, I get time period 10, which is the last time you see an element of that linear gradient series. So that one should be okay. Now we also have this section of 8s. So these things right here are 8 high that sit on top of the 3's. 8 plus 3 is equal to 11. And there are 1, 2, 3, 4, 5, 6 of those. So I'll put a 6 right there because that's the number of elements there are. And I know I've got to do some time shifting, and it ends in time period 16, so that one should be a 10 because the n plus the exponent that's there should equal to what you have, see the last time period of that element of the series. So that's what the present value of this particular cash flow should look like. This is Essential Question 2, version 4 in the fall of 2011.